Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. We are here with another numerical on oscillations, and this is peculiarly based on seconds pendulum. I think I have missed out on this topic called seconds pendulum. I'll make sure that I'll be posting the video on seconds pendulum very soon. So let's just see what the seconds pendulum's question is all about. So you can pause the video and go through the question. I'll just mark the important aspects of this. So they are telling us to find the change in length in seconds pendulum if the acceleration due to gravity at a place changes from 9.75 to 9.8. So there is a chance, there is a change in acceleration due to gravity from 9.75 to 9.8. So I'll represent that data into a tabular form. So what is given to us is it's a seconds pendulum, and in a seconds pendulum they have said that g1, that is the acceleration due to gravity at a place, is 9.75 and at another place it is 9.8. So what would be the change in length for a seconds pendulum? Now before we go ahead, since I have not explained what seconds pendulum is, a seconds pendulum is a pendulum whose time period is equal to 2 seconds. So if there is a pendulum who is oscillating somewhat like this, back and forth from its extreme to extreme, then it starts from, let's say here, it goes to the positive extreme and then comes back to its original position, that is the negative extreme, and the time required for this particular oscillation is what is called as 2 seconds. So if a pendulum whose time period is 2 seconds, we will call such a kind of pendulum is seconds pendulum. So basically, when a pendulum oscillates once, that's called as the time period, and if this is 2 seconds, then the time period, then the pendulum is called as seconds pendulum. We'll be discussing more on this when I prepare a proper lecture on seconds pendulum. So they are asking us change in length, so we are supposed to find out change in length. Okay, so we are starting with a formula called as T is equal to 2 pi root of L by G. This is the formula for a pendulum, time period of a pendulum. So we have already derived this formula in regular videos. I'll square this term, so squaring everything will cancel this square and root, and pi will become square, 2 will become 4 and T will become T square. L by G will be free of the root. Then since I want change in length, I'll try to make L as my subject and everything on the other side. So G goes that side, pi square 4 is also coming down. So I'll get L is equal to T square G upon 4 pi square. Now we'll create two equations out of this. One is for first condition, and then for the second condition. So I'll see L2 is equal to T square G2 4 pi square. Now you'll say, okay, why is not 2 in place of T? Because it's a seconds pendulum, and seconds pendulum the time period is 2 seconds, which is same for both the conditions. So because T is same, I have not put 1 and 2 in these cases. However, G is changing, so G is 1 and G is 2, 4 pi square as it is, and L2 and L1 is changed. Now I'll subtract them because I want change in length. So L2 minus L1 would be equal to, now just put in the values. So L2 ka value is T square G2 upon 4 pi square, and L1 ka value is T square G1 upon 4 pi square. This is nothing but change in length. Change is represented by a delta, which is equal to, now T square 4 pi square are common, so I have taken that common. G2 minus G1 remains inside the bracket. Okay, after that, if you see, if I have put the value T is equal to 2, so 2 square as 4, and this will, both will get cancelled out, pi square will remain. I have put the value of 9.8 in G2 and G1 as 9.75 as it was given in the given condition. Okay, so coming back to our solution, now I'll cancel the 2 square and 4. So there is only pi, and pi ka value is 3.14 the whole square, and 9.8 minus 9.75 comes out to be 0.05. Now from here on, it will depend upon your board on which you are depending on, like which kind of board you are in. Like if your board allows calculator, then this will not be a problem. In case if this question has been in an MCQ and you have 4 options, then you can always approximate the values. Like 0.05 divided by pi square is approximately equal to 10. So final answer would somewhere around be 0.05. So this is only when you have an option and when the options are not very far off. But in case if your board is not allowing calculator, and if in case your board is not allowing MCQs, like this question is not been asked in an MCQ, then you are supposed to apply logarithms. I have applied this logarithm because this is a very unique method of calculation by log. So I'll apply log, and in case if you are not familiar with log, I have a complete playlist on logarithm. You can go and check it out on my playlist, where log and anti-log has been discussed pretty detailed with lots of examples. Now wherever there is a division sign, so there comes a minus. So log of 0.05 minus log of this power of 2 comes ahead, so that is 2 log of 3.14. Okay, these are properties of logarithm which we can use here. Then log of this number will come out to be as bar 2.50, like mantissa will be 50 0 0. So 50 ka row, 0 ka column, 0 ka mean difference, and that will come out to be 6990 minus 2 as it is, and here the characteristic is 0.314. 314 will give out to me 4969. Now these numbers are coming from a table of logarithm. In case if you do not have a log table, then you will have to have a log table if you want to go from this step to this step. Without a log table you won't be able to land upon this step. Okay, now then I'll just multiply this. So 2 is multiplied to this regular multiplication, so 0.9938, and then there is something called a subtraction. Now this subtraction is something really different over here, which is what I was about to highlight. So if this is that number, if you can see, 10 minus 8 is 2. When I have borrowed over here, this will become 8. So 8 minus 3 is 5. So this was 10. 8 minus 3 is 5, and because I have not borrowed here, this is 9, and 9 minus 9 goes to 0, and 16 I'll be borrowing 1, and that will be 16. 16 minus 9 would be 7. Now because I have taken 1 from here, because this is a negative number, so whenever you borrow 1 like this, when this was borrowed, when 1 was borrowed here and when we made 10 over here, this number became 8. That means this number reduces by 1. So minus, this is bar 2 is as good as minus 2. So minus 2, if you remove 1 from minus 2, it will become minus 3. So it is minus 3 minus 0, that will give me minus 3, that is called as bar 3. So bar 3.7052 is the subtraction. You can just rewind the video and just see the explanation again for this subtraction. Whenever you borrow something, the number which is ahead reduces by 1. So this minus 2 has become as minus 3. Okay, now comes the antilog. Whenever you have a single number in the table, in the antilog bracket, you can just find out the antilog. Antilog is always starting from after the decimal point, so you need to see the mantissa of 75.2. So when you see 75.2, you get 5072. You get 5072. Point should always be put on the after first digit and into 10 raised to whatever number is over here, you should put that in power. So this is the way how we solve for log and antilog. In case if you are not allowed to use log and antilog, and if you are allowed to use some other method, then go by those things. Then I'll shift the point. So if I shift the point, earlier it was the point was after 5, so this was the point, and I'm shifting this 1, 2 and 3. So this 10 raised to minus 3 will go off and it will come over here. Also I have made this 7 2 as rounding off rule will apply. So 7 is rounded off to 5.1 and this number will eliminate it. Then meter is not a proper unit of, it is an SI unit, but it is not a proper way, because if the answer is too small, then there is no point in representing that answer in meter. So I have represented that answer in mm. So if you shift the 3 digit, then the answer would be 5.11. Now you will ask me, so you could have done it straight away from here as well. Yes, I could have done it, but because there is a chance that you might go wrong in from meter to mm. So if you want to keep your answer in meter, then stay put, keep the answer in meter like this or like this. Do not convert that into mm. because many boards do not compulsorily ask for mm, they generally see for SI units. So you can keep your answer here, you can keep your answer till here by specifying the unit, and your answer, this would be your answer. This will also give you full marks, this will also give you full marks, and this will also give you full marks. So it depends upon your comfortability, how well you are comfortable in math and moving points and the units. And lastly, length would increase by 5.1 mm. Why is it increased? Because my answer is coming out to be as positive. So because my answer is coming out to be positive, that means the length must have increased. And had this answer come out to be negative, my answer would have been decreased instead of increased. Okay, that is one thing. Also, I can use this logic over here. If t is equal to 2 pi root of L by G, I can take this as like I have done over here, I think so. Yeah, somewhere here. So if you see, if G ka value increases, it is a direct relation, so length will also increase. If G is decreased, length will also decrease. So in the question they have said it is going from 9.75 to 9.8. That means G ka value is increasing. As G ka value would increase, length would also increase. So whatever this answer has been mentioned, this answer has been should have been increases by 0.0051 meters. That's the reason we have written length would increase by 5.1 mm. So if the G ka value changes by such a value, then definitely the length of the second pendulum would also change. Thank you for being with me for so long, and thank you so much for watching the entire video, and subscribe the channel in case you have not done so. Keep following the videos, keep following the playlist in order to get the most out of it. Thank you so much. Have a nice day. Bye.